All right, this is an extension to the last video. So now we're going to really get into our improper integrals. So we're going to have two types. This one is about the infinite intervals. So we're also going to be doing discontinuous integrands in a later video. So let's look at just our infinite. So we can go off to positive infinity, or we can come from negative infinity. And so we have two different ways of looking at it. If you're going to infinity, we use what we used in the last video, and we just replace the infinity with a t, and we go from t to infinity. If we're coming from negative infinity, then we replace the t again with the negative infinity, and we say the limit as t approaches negative infinity. It's nice and simple. Well, what happens if you go from negative infinity to positive infinity? Well, you just draw a line in the middle, right? This is a nice continuous function. So we go from negative infinity to a, and then from a to infinity. And what happens is we then will find the area on the left side. So over here. And then we'll also find the area on the right side. That would be the one from a to infinity. And if we added them together, well, we get the total area. So it makes perfect sense. All right, so let's try one. We're going to do 1 to infinity, 1 to negative infinity, and then from negative infinity to positive infinity. You notice we have the exact same function, but I wanted to pick something that is a little bit involved that we've done before. So our integral here is 1 plus 4 plus x squared. So we're going to be using our inverse tangent. But first, we need to rewrite this. So the limit as t approaches infinity of the integral from 0 to t of 1 over 4 plus x squared dx. So you can notice all we did was replace the t infinity with a t and then put t to infinity for our limit. So now we're going to find this integral. So I'm going to come over here and use that. Actually, we'll do it over on the right side. So we have the integral of 1 over 4 plus x squared dx. And if you remember, the integral of 1 over 1 plus x squared is equal to the inverse tangent of x. So that means we need to have a 4 in front of this x squared in order to pull out the 4. So to do that, we say our x squared is equal to 4u squared, which means really our x would have been 2u. That's the one we're using. So dx is 2 du. So we can now plug it in. So we end up with the integral of 1 over 4 plus 4u squared to du. And then we rewrite it. So we're going to pull out the 2 that goes in the top. The 4 goes to the bottom. So we end up with 2 over 4. And now we have 1 plus u squared. And so this is 1/2 inverse tangent of u. And then what is our u? Well, our u is x divided by 2. So our u is x over 2. So this would be 1/2 inverse tangent x over 2. All right, so now we know that the integral is going to become 1/2 tangent inverse x over 2. We now can just replace it with a little bar and t. So now this becomes the limit as t approaches infinity of t and 0, just like that. So all I have to do now is bring that one down, the t and 0 down, and now we can plug them in and find our actual limit that we're using. So the limit as t approaches infinity, so this is where we started, is right here. And now we're finishing our limit of 1/2. So I'm going to pull the half in front, and we get inverse tangent of t over 2 minus inverse tangent of 0. All right, so if you remember, what's inside here is the reverse of tangent. So this is really just saying as tangent is approaching infinity, what is our angle approaching? And that would be pi over 2. And then at 0, we get 0 for tangent no matter what. Plug in 0 for tangent, you get 0. So plug 0 in for inverse tangent, you get this. As our angle approaches pi over 2, our tangent would be approaching infinity. They're backwards there. All right, so now we have a half here. And so we end up with pi over 4. So the integral from 0 to infinity of 1 over 4 plus x squared dx is equal to pi over 4. All right, so now let's try it with negative infinity. Now it's going to be the same thing, except we're going to negative infinity. So we already have the integral, so we're going to take this a lot quicker. And so now we're going from t to 0. And so this would just equal the limit as t approaches negative infinity, and we already found the integral. So all we're really doing is changing that to a negative infinity, putting a 0 here, and the t at the bottom. So we'll put the half in front again. Oops. Just like that. Oops, not like that. Don't do that. 0t. So because we're coming from a negative infinity, so the t's at the bottom, it's at the bottom. Here the t is at the top, it's at the top. So there we go. Now we just have to figure out what that one is. And it's the same way. So we have 1/2, the limit, and now we can substitute our 0 and our t in. All right, so this is 0 just like before, and so that one is 0. Minus. Now we're doing negative infinity. So if you remember with our tangent, I'm going to draw a picture this time so you can see it. We have our vertical asymptotes at negative pi over 2 and pi over 2, and that's our tangent. All right, and you can graph this as well just to look and see what's going on. But our tangent here is approaching infinity when x is approaching pi over 2. So that would mean that our inverse tangent is approaching pi over 2 as the inside approaches infinity because they're backwards. So as we're approaching negative infinity, our tangent would be approaching, our x would be approaching pi over 2. So as the tangent approaches infinity, our inverse tangent is approaching negative pi over 2. All right, so that would give us pi over 4. So the integral from negative infinity to 0 of 1 over 4 plus x squared dx is equal to pi over 4. So now if we put them together, we take that one and you basically just click it to that one. Think of like a little magnet there. It would look like this. And that's our area from negative infinity to positive infinity. So we would be taking the first integral, that the integral from negative infinity to positive infinity of 1 over 4 plus x squared dx is equal to, and I picked 0, so we would go from negative infinity to 0, because if you plug 0 into a tangent, it's 0. So it's a perfect number to pick. You want to pick correctly. All right. So then we have the 1 over 4 plus x squared dx plus the integral from 0 to infinity of 1 over 4 plus x squared dx would equal pi over 4 plus pi over 4, which equals pi over 2. So there you go. And again, you can plug these in your calculator to verify them, to make sure they are what they are. And we can also use Desmos. So if you plug this in your calculator, you'll see that it approaches pi over 4. So if I plug in the 1/2 inverse tangent of t over 2 minus inverse tangent of 0, I go to my table set, and we're starting at 0 to infinity. So I made my change in table 100. We get this. And so if you check pi over 4, you'll see it's 0.7853. See, there you go, 398. And so it checks perfectly with your calculator. And you can do the other side the same way. It would be going to negative infinity. So all we would have to do is make our table set a negative. So now we're going off to negative infinity. And you can see it's the same thing, just with a negative there. Now remember, the reason it's coming out negative is these are backwards. So you have to remember that. I plugged them in backwards here, see? So if that was really coming out negative, it would really be positive, which is what we get. And so again, my A is 0. Here's Desmos. My B is now at 1700. And as I keep getting larger and larger, you can see we are approaching it. So as our t goes off to infinity, this is going to be becoming pi over 4. So if you're given a negative infinity, pick a number that's nice in the middle to cut it up. That will work out. And if that means that you need to take the integral first, because you're going to be using it for all three anyways, go ahead and do the integral first, see what you have there, and then see what is that second number that you can plug in that's nice. And then that's where you want to cut it.